Okay, and welcome to this video where we look at different types of graphs which you'll need to know through the A-level course, and you'll need to be able to recognise in a sketch with different equations in each of these categories. Okay, the first type we're looking at is cubics. So cubic equation looks something like this. In a quadratic equation, the highest power within that equation has a power of 2. In a cubic, the highest power is of 3, and it decreases in powers until it gets to a number. The points where the curve crosses or touches the x-axis should be labelled. This is very important, and students at A-level sometimes forget this, that detail in your sketches are very important. The roots can be found from the factorised form of the equation. So learning how to factorise is very important even when it comes to cubics. The y-intercept can be found by letting x equal to 0, or substituting x equals 0 into the equation, or in some cases by reading the cubic and finding what the number is at the end, this d, if it's shown there. The shape of the graph can be determined by examining how the curve behaves as x tends to infinity, plus or minus infinity. Now what does that mean? If as x approaches positive infinity, which basically means goes up and up and up in value, as it increases in value, you can sort of think about, okay, what if I put in a really large x value into the equation, what's happening there? What if I put in a really large negative x value, what's happening there? Okay, so as x goes to positive or negative infinity, you can think about the shape of the graph. A cubic function with one repeated root, real root, will result in a point of inflection. And a point of inflection, we'll see that in an example later on. Okay, it's quite important that you understand what happens when with one repeated real root. So here we go. Now, as I said, when we do sketches, and I've done this in a previous video, when we do sketches, you will have to use a pencil and ruler. Now, when you do your sketch, remember you do not need to write 1, 2, 3, 4, minus 1, 2, etc. on x or y. That's a plot. We just need the most important information and gather the rest from it. So the first one, x minus 1 cubed. So, okay, before we get into that, actually, there's two types of cubics that you might see. This on the left hand side is what we call a positive cubic. So if you've got a cubic which has a positive, if it's got a 1 or positive number outside of it, it will exhibit this sort of characteristic. It will go from bottom to top, okay, and it will exhibit this sort of characteristic. If you've got a negative cubic, it will exhibit this characteristic. It will go from top to bottom, okay. And obviously, if you don't believe me, you can try it yourself. Plot these graphs by putting in different x values. Anyway, so going back to this x minus 1 cubed, what would that look like? Well, what would be a good start would be to think about what that means. X minus 1 cubed means x minus 1 times x minus 1 times x minus 1. That's the factorised form, fully factorised form. And if you remember what we did with quadratics, once I've got the factorised form of quadratic, we made those brackets equal to 0 to get the x values. Similarly, if I do this here, if I make all these brackets equal to 0, I'll get one x value, and that is x equals 1. So that is my x-intercept, and there's only one value, there's no other x-intercepts, okay? Now, I know if I was to expand the brackets, x times x times x, I'll get an x cubed, okay? Which suggests that the shape will be like this on the left-hand side here. So we're going to definitely see something like that. But what would be the y-intercept? Now the y-intercept you can get quite easily by multiplying the numbers by themselves. Minus 1 times minus 1 times minus 1. And when you do that, minus 1 times minus 1 is plus 1, times by minus 1 again, you get minus 1. Okay, so you can have some stuff in the middle, which we don't really need now because we only need the x and y-intercept. We know what the shape will look like because we just expanded the x terms, and we've got minus 1 as the y-intercept. Okay, and there's no other x-intercepts, so it's going to exhibit this sort of characteristic. Okay, so if you look at this, x minus 1 cubed, what's the difference between x cubed and x minus 1 cubed? Well, the x-intercept was 0, but now it's 1. So you can see it's been moved to the right by 1, or you'll see this in transformations later, it's been translated to the right by 1. Okay, the next example is example 2, where we've got x minus 2 squared and x plus 3. Now if I was to just simply look at these brackets, okay, I've got x minus 2 squared, which means you've got x minus 2 times x minus 2, and you've got the x plus 3. Now if I made each of these brackets equal to 0, I'll get 2x values. I'll get x equals 2, and I'll get x equals minus 3. Okay, now the issue here is that it will intersect at minus 3, but we've got a repeated root here, x minus 2 squared. A repeated root is where you have x minus 2 times x minus 2. Okay, it's repeated. Like here, you've got a repeated root, yeah, but it's repeated 3 times. We've got a repeated root here. Okay, so we're going to have a point of inflection. Now, I'm going to do a sketch. And when I do the sketch of this graph, I'm going to have a point of intersection there, 2, and a point of intersection there, minus 3. And now we have to make sure we get the direction of the cubic graph correct. So if I did x times x times x, I'll get x cubed, so it's going to be a positive cubic. And now we have to decide the y-intercept. So we've got minus 2 times minus 2 times plus 3, which will be 12. That will be the y-intercept. Okay, so I'm going to have something which will look like this. It's going to cut at minus 12, sorry. And it's going to come down, and we're going to have a point of inflection at 2 because it's a repeated root. So let's just have a look at this. And that is our point of inflection. Okay, so it's just a point at which it will touch the x-axis and carry on going up. Okay, so that is how we deal with a repeated root. Okay, so let's have a look at this one here, part C. X cubed minus x squared minus 2x. Now this is not in a factorized form, which can help me get x-intercepts, so the best thing to do would be to get it into a factorized form. Let's factorize it. I'm going to take x out. Okay, sorted. Yep, it's been correctly factorized. Now we've got to get the x-intercepts. If I make each of these equal to 0, I'll get an x-intercept 0 at minus 1 and at 2. Okay, so I'm going to get my x-intercepts there, and the y-intercept, if I made x equal to 0, which is another way of getting the y-intercept, I'll get 0 times 1 times minus 2, so the y-intercept is also 0. Okay, so it's going to cut at 0, minus 1 and 2. It's a positive cubic, so it's going to exhibit this sort of personality or this characteristic. Okay, so it cuts through at 0, and the y-intercept is also at 0. Okay, so coming up to the final one now, we've got x minus x cubed. I'm going to factorise x from this. And this can be factorised further. If you remember from GCSE, difference of two squares. Okay, and if I find the x-intercepts, I'll get 0, minus 1, and 1. Okay, and the y-intercept is 0 as well, because there's no other value in that cubic equation. So I'd have 0, cuts at 0 here, 1, and minus 1. Now we've got to be careful with this. This is a negative cubic because we've got minus x cubed. So the nature of the graph, characteristic of the graph, will follow this sort of pattern. Okay, so it'll go from top to bottom in this way. Okay, so if I draw this, okay, have that sort of pattern there. So that's the graph x minus x cubed, and that's how we sketch cubics. So let's recap. When you have to sketch a cubic, first thing you have to do is think, okay, is it in factorised form? If it is, like these two, then what x roots can we get from that? What roots can we get that I can plot on the x-axis? If I've got a repeated root, then you've got to remember it's going to have a point of inflection. Okay, it's not going to cut through. Okay, and once we've got the x-intercepts, how do we get the y-intercept? Well, you can either read off the equation if you can see the d, or expand the brackets, just the numbers, and see what number you've got on the outside. Okay, so like I did here and I did here. Okay, and then if you've got cubics which are not factorised, you've got to factorise it yourself and extract that information. And obviously look at the sign, is it a positive cubic or a negative cubic, and that determines the direction of the graphs. Okay, so the practice questions are outlined here, and it's good to have a go at this because you'll be doing a lot of sketching during the A-level course, and good luck. That's the end of the video.